Welcome everyone to this explainer. Today, we're going to look at what is without a doubt a true billion-dollar masterpiece of extreme engineering. We're talking about a scientific marvel that involves hundreds of the brightest minds and literally took decades to pull off. All to create the single most precise experiment human beings have ever built. We're going inside LIGO, and let me tell you, it is an absolutely fascinating journey.
But to really understand just how crazy this whole thing is, you first have to picture the sheer physical scale of it. Imagine driving out into the absolute middle of the desert, miles and miles away from any city, any traffic, any vibration at all, and you stumble upon these massive, continuous concrete tubes housing huge metal pipes that just stretch on and on for 4 kilometers. You'd probably be thinking, why? Why go through all the unbelievable trouble and expense to lay down a giant laser facility so far away from civilization? Okay, let's dive into this. Section 1. A new cosmic sense, from seeing to hearing the universe. To answer why this colossal machine was built, we have to understand its primary goal.
Up until very recently, for literally all of human history, everything we knew about the cosmos came from waves of light and particles that just happened to hit Earth. We were essentially only seeing the universe. Think about it like this. Imagine you're standing in the middle of a really dense, dark jungle, and you can only use your eyes. Think about how completely limited your awareness of your surroundings would be. Now, imagine suddenly, for the very first time, being able to hear. Think about how much more you'd instantly know about what's hiding in the trees around you. Well, LIGO was built to do exactly that for the cosmos. It lets us stop just looking and start actually hearing the universe through gravitational waves.
Section 2. The impossible measuring stick. Testing a 100-year-old theory. You see, building a machine to actually hear the universe wasn't exactly a simple weekend project. When scientists started planning this back in the 1990s, they were making a massive billion-dollar bet on a cosmic physical problem that was already over a century old.
The entire project was actually based on a pretty wild prediction made by Albert Einstein way back in 1915. Einstein theorized that when massively heavy objects, like 2 enormous stars sitting hundreds of light years away, collide, they don't just produce light. Because massive things actually warp the space and time around them, their collision sends out invisible ripples traveling at the speed of light. These are gravitational waves. And the crazy part? As they wash over Earth, they literally stretch and squeeze all of reality. You, me, the screen you're looking at, the space between us, everything gets momentarily warped.
So the crucial point is, why don't we feel it? Well, physicists knew that even if Einstein was right, this stretch and squeeze would be microscopically unbelievably tiny. In fact, it'd be 10,000 times smaller than the size of a single proton. Trying to detect a physical change that small is like trying to measure the distance from Earth to the nearest star, which is 4 whole light years away, by the way, and trying to notice if that massive distance changes by the width of a single human hair. It's just almost unfathomable.
Section 3. Engineering the extreme. Inside the 4-kilometer vacuum. To capture a measurement that impossibly tiny, scientists had to build the ultimate measuring stick. So here's the exact journey of how they actually pull this off. First, scientists take a super powerful infrared laser and split it perfectly into 2 identical beams. Then, they fire these beams down those 2 4-kilometer-long concrete arms in the desert. Because a passing gravitational wave might stretch one arm while slightly squeezing the other, the distance the light travels will change ever so slightly. Now, to make the measuring stick even longer, they cleverly bounce the light back and forth off mirrors about 300 times before recombining the beams at a detector. Since the speed of light is completely constant, if a wave passes through and alters the length of those arms, the light waves will no longer cancel each other out perfectly. And the result? The detector registers a tiny, tiny little flicker of light.
Now, what's really interesting about this slide is the sheer extremity of the conditions required here. To make sure this tiny flicker is actually a cosmic wave and not just, a truck driving by, requires pure isolation. Inside those tubes is 10,000 cubic meters of nothing. Literally, there are fewer particles inside there than what the International Space Station flies through in outer orbit. The laser builds up to 400 kilowatts. That's 80 million times more powerful than a standard laser pointer. And the 40-kilogram mirrors, they reflect 99.9999% of the light. They even had to hang these heavy mirrors on perfectly spun glass wires just 4 times thicker than a human hair to make them 10 billion times more still than the natural vibrations of the Earth itself.
But even with all this unbelievable space-age technology, they still ran into some pretty funny, deeply earthly problems. For instance, in 2018, some clever local ravens discovered that frost was forming on the cooling pipes outside the detector in the desert.
When these thirsty birds casually pecked at the icy pipes to get a drink, those tiny, tiny little taps created vibrations that traveled all the way into the facility and completely ruined the data. It really highlights the mind-boggling sensitivity of this machine. They eventually had to go out and insulate the pipes to deny the ravens their frosty treats just to save the experiment.
Section 4. The sound of black holes. The agonizing wait and the first chirp. So they fought off the ravens, they isolated the mirrors perfectly, and they finally turned it on. And what did they find? Well, for a very long time, absolutely nothing. It was a brutal stretch, to be honest. After all that construction, from roughly 2005 to 2015, they experienced a full decade of agonizing, absolute silence. No flickers, not a single gravitational wave, just dead quiet. But they didn't give up. They kept tinkering, making the machine better and more sensitive. Finally, in September of 2015, they turned on the newly upgraded advanced LIGO. And almost immediately, just 3 days later, they struck gold.
The detector suddenly registered a flicker. It appeared as just a small little bump on a chart. Scientists affectionately call it a chirp. Now, to be absolutely sure it wasn't just another raven or local noise, they quickly checked that their second, totally identical machine that they had built 3,000 kilometers away, it saw the exact same chirp. They had actually done it. They proved Einstein right exactly 100 years after his initial prediction. That tiny bump ended up winning them a Nobel Prize because they quickly realized they were literally hearing the massive cosmic collision of two huge black holes that merged 1.3 billion light-years away.
Let's move to and see how this builds into Section 5, expanding our universe, the era of cosmic hearing. Because as it turns out, that single monumental discovery wasn't the end of the story. It was just the very beginning. See, that first chirp was absolutely not a fluke. It turns out the universe is actually incredibly noisy. It's yelling at us constantly. To date, we've made 294 confirmed detections. In fact, right now as we speak, LIGO registers a cosmic collision about once every 3 days. We are constantly hearing stars smashing into each other, exploding, and black holes colliding in the dark. And the really exciting part? Our cosmic hearing is rapidly improving. When they first turned the machine on back in 2005, the reach just wasn't sensitive enough to hear the cosmos. By 2015, they finally had the volume turned up enough to catch that first black hole merger. But today, the technology has advanced so much that our reach covers 1,000 times more space volume than it originally could. These sounds are now allowing us to do incredible things, like measure the speed of gravity and actually track the expansion of the universe in real time. And honestly, we are just getting started. If you think a 4-kilometer measuring stick is insane, you have to look at what's being planned next. Europe is currently planning an underground triangle observatory with massive 10-kilometer arms. Over in the US, there's a plan called the Cosmic Explorer, which envisions a giant L-shaped machine with mind-blowing 40-kilometer arms. The ultimate goal here is to keep expanding our cosmic hearing all the way out to the very edge of the observable universe.
Humans really are astonishing, aren't we? We literally gave ourselves and every single generation after us an entirely new physical sense. We're likely the first living species ever to sense the cosmos in this profound, incredible way. The universe has been talking to us this whole time, and we can finally hear it. So as we build bigger and better ears for our planet, the ultimate question remains, what hidden secrets of reality will we hear next? Thank you so much for joining me for this explainer. I really hope this helped you wrap your mind around one of the coolest things humanity has ever built. Keep learning, stay curious, and I'll catch you on the next one.